Hello guys. Today in this video we are going to discuss about curl, okay, and how to write this curl of a vector field in integration form or in the form of an integral, right? So here mathematically we can just write it as curl of a vector field. So in the determinant form we have already written it and have expanded it earlier in the previous video, so you can just refer to that. So I will just write this as limit, okay, in the integral form. Del S tends to 0, where del S is that infinitesimally small area I'm referring to. And here I can write the closed integration, okay, of contour integration, closed contour integration. So contour means it represents like line, okay, or line segment, okay, on any plane. So that, okay, now here I'm writing as the vector field, okay, on which the curl is operated. So a dot dl, dl is the length element or the elemental length, okay, divided by del s, the surface area, infinitesimally small surface area, and then n cap, as del cross a is a vector, we all know that. So del cross a or curl of a vector field gives you the rotating effect of the vector field at any point. So right, so whether the vector field has a rotating effect or not, that can be determined by just finding out its curl, right? So you operate this del operator with a cross product on that vector field and see whether the curl exists or doesn't exist. If the curl exists, that means there is a rotating effect, right, along what direction the vector will be directed, okay, and the magnitude of the rotational effect can also be determined, right? If the curl doesn't exist, that is, it is zero, it is irrotational vector, that means it is not, like it is unidirectional, moving in only one direction, and there is no change in the direction, and there is no change, I mean there is no rotational effect of that vector field. So this is what we know. So here what we wrote, the physical significance of this statement over here, that we defined or we wrote in the integral form, as we wrote in the integral form, what is called, okay. So here we can say the curl of a vector field actually what is the limiting value, limiting value of what, limiting value of its line integral, okay, line integral of what, line integral of the vector field over a closed path, you can see a closed contour or closed path, right? Per unit area, here we consider this surface area del s, which is actually created by this closed path. I will show you what is that, okay. Per unit area bounded by this path, as I said, bounded by the path, as the area tends to 0, as this area tends to 0. So now you just take, like, in one dimension and sorry, in two dimension or three dimension, whatever you want to take, you can just take that. Suppose here you, like, you take your coordinate, okay, like your space coordinates in Cartesian form, I have shown you x y z, right? And then here suppose you are moving, like, I'm just trying to do it on actually it's three dimensional, but I can just take it on the xy plane over here, whatever, just for simplicity. Suppose you are moving in this path, right? So you move from a to b, and then you move from b to c, and then c to some d, and then from d to a. So suppose this is the path, okay, through which the vector actually moves from a to b, b to c, and then c to d, and then d to a, right? So here you can see this is a b, the line segment b c, c d, d a, they are all individual paths, okay. Now this, they actually, they are closed, okay, you can see they are connected. So these paths are actually connected to make you what, to give you a surface, right? So to give you the surface which is enclosed by this, this path. Now if I will consider like dl small length elements, where the vector field actually passes through a dot dl, that is given by a dot dl. So a dot dl is this small length segments I showed you, and how the vector field actually goes through all these path a to b, and then b to c, c to d, and d to a, okay, that will be given by what, this closed integration of a dot dl, right? Now this a dot dl in terms of magnitude you will definitely get, because you can see this is the magnitude. A dot dl will always give you a scalar value, so it's magnitude. Per unit area, per unit area is what? So if I will say this encloses some area, then per unit area I said, so per unit area we consider to be this infinitesimally small area. So per unit area, when the area tends to 0, right? And you see this n cap. Okay, this n cap is the unit vector along the direction of del cross a. Del cross a means what? The rotation, right? In which path you are actually moving. So the same rule is applicable, like in cross product, or you said curl of a vector field we used. So if it is counterclockwise, you just your fingers, all the fingers in the right hand rule, okay, right hand thumb rule, all the fingers will be in the direction of its curl, and the thumb will represent the direction of the vector, area vector. So here, if it is counterclockwise, you can see the thumb will be upward. So upward can be shown upward to this plane. So I can show it by your dot. If you are moving in counterclockwise, clockwise, okay, in this direction, this is anti-clockwise or counterclockwise, here it is clockwise direction, then your thumb will be downward and the curl of the fingers will be in this direction, in the clockwise direction. So downward we can put a cross like this, so perpendicular to the plane, but it is inward, right? So the direction will be given by this unit vector n cap, right? So what we said here, this n cap is the unit vector which is normal to that area element, to this area element. So the area element actually is will be given by this closed contour. In what direction actually moving you are moving? Are you moving from A, B, C, D and then A, or you are moving in this direction D, C, B, A and then D, right? So accordingly you can decide what is the n cap value. Okay, so here uh, you know we got the curl is represented by this. So actually the curl gives you what? The rotational effect of the vector field, right? So the same thing we considered over here, when the vector actually passes through in this particular path, through a particular path, okay, by small elements dl you have taken. So a dot dl actually give you what? I mean, here you can see the what variation of the vector field along this particular path, which will be given by a dot dl, and this closed path actually encloses a surface area. So that surface area we said. So per unit area, what is the change we got it when the unit area, or the area we have considered is infinitesimally small, okay, and the n cap gives you the direction. So this is how you can actually represent the curl of a vector field, which we said del cross a, in an integral form, or in the form of an integration, right? The differential form we have already discussed, and you can refer to my other video where we wrote the I cap, j cap, k cap, the unit vectors, and then the del operator, the components del by del x, del by del y, del by del z, and the vector components ax, ay, az put it in the determinant, and then we expanded it. So we have already discussed the significance, physical significance of del cross a and its differential form. Now this is what is the this is the form in integration, right, or integral form of curl of a vector field. Okay, hope you like the video. Please subscribe it. Thank you.